Hello and welcome to our video on AI filters. We're using version 1 Professional. This video is about the extra functions and settings for the neural network. It shows you how to configure it correctly and what you can do with it. Let's load a before image and a suitable after image. Let's have a quick look at them on the comparison screen here. On the left we can see the original image, and on the right I've made a comic drawing from it. So we'll now try to convert that into an AI filter using a neural network, and to get the settings for that as correct as possible. What do we mean by that? Well, below the before and after images you can see the settings area for the AI network. Here's the block size. This is the first setting. Next to each level of settings you can find a blue eye. You can click it to display information about the settings. It's basically a description or a guide for what happens here and what the settings do. We've decided to put all that into words again in this very video because it might help you understand it a bit better. Our before and after images and the block size, how are they related? Let's take another look at that. Let's take the magnifying glass and look at the lines here. How big are these lines? How thick are they? I'd say the average is 3 pixels for the thickness of the contours in the comic style. That means it would make sense to set the size of the image blocks to 3 pixels. By doing that, you're telling the network, please use blocks of 3 by 3 pixels for the calculation for the training. And any structures and structural changes of this size can then be learnt by the network. If we have smaller changes, then we need a smaller block size. If we have very large changes, we need a large block size. The mathematical network becomes more and more complex, so the equation gets bigger and more calculations are needed. The training rate area is the second parameter down here. It tells us exactly how the network is to be trained. That's how many training blocks are taken from the before and after images to train the network. The more blocks or training elements we take, the more accurate the picture will be, and the longer the training will take. The first setting takes about 500 training elements from the before and after images. The second takes about 2,000. Third takes 8,000 training elements. And the last setting, the largest one, takes around 30,000 individual elements, which are picked out from the image here. As you can imagine, takes a bit longer because a lot more calculations have to be performed. In our case, let's keep it at default level 2. I'd use that whenever I'm trying or testing something out with an image. For AI filters, to train your normal final filters, then feel free to choose the third level, which gives you a very high level of accuracy. The third level of settings contains the network layer shapes. So how the AI network is structured. It doesn't mean the layers in image processing, but the layers in the neural network. Network is structured in different layers. The first layer is the starting layer. That's where your image pixels go. It's followed by the first computing layer, then the second, and so on, until we finish with the resulting pixels. And it's exactly that shape that you see here. The first layer is always complete. That's your starting pixels, and the level of complexity involved comes after. The flatter it is, the more simple the structure. In our case, we have contours that have to be detected, a bit of a change in brightness. These settings are very good for these conditions. If you only have changes in brightness and color in your image editing, configuring this first setting is enough. Computing is very quick in this case. If you're doing very complex things like generating micro details or determining sharpness, then choose the fourth or fifth setting. Basically, the more complex the things you do to the image, the higher you have to set the layer structure. We are going to stay with the second setting. The fourth area is called additional functions. The first setting is activated by default. This option includes gradients, vignetting, and things like that in the training. That's not needed in our case. If we look at the before and after pictures again, there's no brightness, there are no color gradients on them, no vignetting, so we don't need the gradients. Let's switch that off. The next setting is the additional color area. If we take a look at our before image, we see we have a lot of pink, a lot of green, but we can't really see any deep blue or strong reds or even yellows. If you activate this additional color, click, then different variants are automatically generated from the before and after images with different coloring. This is called data augmentation in the technical language of neural networks. That means that additional data is generated from your data and used to make the color mapping more stable overall for colors that don't appear in the training material. The same applies here again for the contrast. So if the contrast isn't fully utilized, that is, if there's no black, no white in your before and after images, you can activate the additional contrast. The last setting at the bottom is the convolutions, or the mathematical convolutions. They allow us to detect changes in detail, brightness and texture over large spaces. So if we use an effect like soft detail or a detail enhancer, then we can enable these changes in detail over large spaces and the network is able to learn them. Another feature you can use with that or on its own, depending on your needs, you can also tell the program and the network about changes in detail in a smaller area, which I'd recommend here because we're making a black line out of a contour in the image. That's definitely a change in detail in a small area. And if you have this change in detail for the convolution with the different colors, like here, pink, green, a little turquoise, then you can activate color recognition for the convolution. Now we've really set up our network well. We're now at the point where we've had a quick look at each aspect of what makes sense here. Now let's train our network. I'm going to put in 10 iterations. That's now set to 10 iterations, and now we'll train it. Now let's see what happens. After 10 iterations, we see that the contour mapping is very, very good. The black lines, comic style is already emerging, but the color mapping is not great yet. We still have a bit more training to do. It's going to take a while to train the color in here. It could easily take a couple of hundred iterations, but that doesn't matter because each iteration only takes 0.4 seconds. It's relatively quick. I'll do another 10 after that. Then I'll take a little shortcut because I trained the network earlier through to the end. That is, until the automatic check said it couldn't go any further. And I stored that here as the comic network, which we'll take a look at now. So after 594 iterations in 16 minutes of training, which is quite a long time to let it run, our result looks like this. We get a really beautiful, stylized version of our original image, like our before and after images have shown, and the network has now trained that. And we can now use this network, this AI filter, whenever we want in the future. I hope we've helped you with these settings a little bit. Once again, keep an eye on the little blue eye buttons next to the settings here. They all give information about what the settings do. I hope you enjoyed working with the program. See you next time.